and do a presentation on this. So we're going to just go over Ohm's law. So we've covered some of the basics, and we've covered some of the basic mathematical equations and things. So we're just going to go back to the basics of Ohm's law. Everything that you do will come back to Ohm's law, even when we're doing testing or we're doing more advanced design project stuff. It still relates back to some basic Ohm's law. So the current, which is the uniform flow of electrons through a conductor, is referred to as electrical current, and the unit of electrical current is ampere, A, big A. And the formula, the symbol in the formula for electrical current is I. But that's very confusing that we've got current, A, and I, but it will become more clear the more we use it. Electromotive force, EMF. The EMF provides a difference in potential between two open terminals in an electrical circuit. When the circuit is complete, the potential difference causes the electrons to flow in a uniform direction around the circuit and produce a flow of current. The unit for EMF is the volt, and the formula, the symbol for EMF is volts. So what we'll do a lot, especially when we get into a bit of magnetism and we talk about transformers and things, throughout the electrical science unit, we will hear things called like a potential. If we have a potential between 2 points, we are referring to a voltage. If we're talking about an EMF, we are talking about a voltage. Most of the time, when you're dealing with what you deal with, you'll deal with volts. Yeah, and it'll be AC voltage 230, or if you're dealing with low power systems or you're dealing with lighting circuits, it's 12 volts or 24 volts. But you will come across every now and again in some City and Guilds literature and in some details EMF. So EMF is volts. And resistance. Every circuit presents some opposition to the flow of current. In the electrical circuit, which has to be overcome by electrical pressure applied, the opposition is called resistance, and the unit of resistance is ohms, with a little omega sign. And in formula, the symbol for resistance is R. Now we will deal with resistance all the way through the electrical course. Every cable that you have will have a resistance, all the testing, until we come to some live testing. Most of the testing is high resistance or low resistance. So resistance will be all the way through. So Ohm's law, and we put it into a little triangle. The current flowing through any circuit is directly proportional to the applied voltage and inversely proportional to the resistance of the circuit, provided the temperature of the circuit remains constant. Now, we will go into temperatures when we do the design project, and we'll look at different things like that. But for all of our Ohm's law's equations, we're just assuming that the temperature is constant. So V equals IR, I equals V divided by R, and R equals V divided by I. So we come up with a triangle, and there should be some nifty animation in a second, which will put this into practice, but I don't know if it works on Google. So no, so the Google, because it wouldn't be in a PowerPoint, but basically if you cover the R, if we covered the R up, let me get this pointer actually. So if we covered this R up here, we would get IR. So I times R is equal to V. If we covered the R up, we get V divided by R, gives us that. So we can work out from that little triangle, if we cover up one of them, what two are remaining is the equation that we need to do. So in this example, an EMF of 10 volts is applied to a resistance of 20 ohms. Calculate the current that would flow. So we need to find the formula for I. So we use the Ohm's law triangle. And I do recommend that you always get used to drawing these triangles. And when we get onto power circuits, we do something very similar. And it will just help you remember. So by covering I up, it leaves us with V divided by R. So if we put the figures into our calculator, or we use our head, so 10 volts divided by 20 ohms gives us 0.5 amps, half an amp. So that's a simple little diagram there. So yeah, now the animation works. So as you can see, if we cover up the I, we get VR. So we'll have a similar thing here. Calculate the applied EMF when 2 amperes flows through a resistance of 40 ohms. So we need to find the formula for V. So if we cover up the V, we can see that we're left with I times R. So we end up with I times R, 2 times 40. It gives us 80 volts. And it is always good to draw a little circuit. So if you know 2 things and you have the third remaining, so if you always draw a simple circuit with R, V, and I, put in the figures that you've got for that circuit. So in this case, 40 ohms and 2 amps, which means we have V remaining. So on our third example, we have an EMF of 50 volts is applied to a circuit and a current of 5 amps flows. Calculate the resistance through the circuit. We need to find the formula for R. So once again, we cover up the R and we get V divided by I. So V is 50 volts divided by I, which we can see is 5 amps flowing, which gives us a resistance of 10 ohms. Okay, so I'm just going to come out of that, and if I can just leave that on the end for a second while I go into here and I go over here. And I just stop recording.